Alrighty, happy Tuesday. So, Project Zero today, awesome. Hopefully that went pretty well. Um, and practicing that dynamic memory, using these dynamic arrays, our copy constructor, copy assignment operator, and destructor, and that big rule of three. Um, so you got that today, and then we're going to get into our inheritance for the next project, for project one. So project one will be a project on inheritance. We'll continue on with this idea here. So Um, Project Zero should go relatively quickly. We'll have some time to get started on inheritance, and I'll intro the project, and then we'll finish this up on Thursday for the inheritance section here. Okay. How's the reading going in Zybooks? You're all reading, right? Fantastic. Good to hear. Again, just another point of reference. The more often you see this stuff, the more different ways you see it, the more likely it is it's going to stick, right? If you only ever watch me do it, it's not so good, right? You want more examples. You want to practice it. This way, we got our labs we're going to work on. So we'll do a lab on inheritance, help get you going for this chair is the worst for the project. We'll practice that tonight, and we should have a lot of fun. So let me fire up Visual Studio. I'll go pull up Project Zero, and let's see if we can do some fighting pets. Right. So let's do a new project. And if you put the project in your repository folder, life is good. You don't have to do anything else. So we'll call this Project Zero. Now, we don't actually need anything in main here, but we're going to want to use it and test it and make sure we did things right. Right? If we make a copy, do we actually have a deep copy, not two objects with the same dynamic memory, right? With these sorts of things. So if I go and add a fighting pet to somebody, make sure it doesn't show up for someone else. Those sorts of things here, or change their values, or do whatever we wanted to do here. So I'm going to add a header file. We'll start with the easy one, which is the fighting pet here. So make an H file, fighting pet. So using namespace, standard, and we got to include string. If we want to use strings for these things here, fighting pet. Again, you don't have to do one per file. I like doing it one per file. That's just what I like. I think it makes the Git history really nice and clean. And sure, it's no big deal. So we'll have our private section, public section. So fighting pets were the basic one, right? They've got name, number, combat power. Sets, gets, constructors as appropriate here. Now, depending on if you think something should change, means we should have a set. So if your name can change, you should have a set for that. If your number should change, you should have a set for that. If your combat power can change, you should have a set for that. Right? As far as I know, when it comes to Pokemon, their number never change. I mean, fighting pets, their numbers never change. So if I don't have a set for that, that's fine. If you don't have a set for it, you have to take that argument in a constructor because there's no other way to give it a value. So either way you went here, perfectly fine. I'm not going to mark you down one way or the other for this here. You just have to have ways to set those values. So whatever you think makes sense for your solution is perfectly fine. So I think this is pretty quick and easy. We can have a string for name, we can have an int for number, and probably an int for combat power, something like that. Again, we'd have more attributes here and there, but that's perfectly fine. And I'm going to be kind of lazy here, so we'll just add this in. We'll go to GPT and have it write the sets and gets for us here, because I don't want to have to do that myself here. So please write set and get functions for this class, and we paste it in. And if we're using the tool, we're going to cite our source. We'll say, okay, here's I used / umgpt, and my prompt was this thing here. Having here's all ugly. My apologies. We'll throw in our prompt. That all should get commented here. Let's do control / as a quick way for that. Cool, good enough. And whichever ones we want here, right, we can go and copy. So here's sets and gets, pretty easy. Again, these are not very interesting to do it this way here, and we don't need the standard stuff. And I would get rid of these nonsense comments as well, because why? Why do you have to tell me these are set functions when I can see they're set functions, right? That's not a helpful comment here. So if you wanted number to change, leave a set. If you don't want it to change, well, then take it out, right? You don't have to have that. Maybe your name changes, right? I don't know. Sure. Maybe your combat power changes. I don't know. Whatever you wanted to do here, right? So if we don't have a set for that, we have to have it in the constructor. So we'll have a fighting pet constructor here that takes a int for number, right? And then it would set this number equals the number. Number, there we go. Right. Look at that, new combat power. Okay, sure, why not? And we could also take in the other variables if we wanted to be able to pass in a name, pass in this, however you wanted to set it up. It's not a wrong way, right? There's just however we wanted to go about it. So we got fighting pet. That was the pretty basic one. Now we're going to add trainer. So we'll add a class for trainer. Oh, why did I get a green line here? What is it not like? What's the green line? Really? It's not telling me. Oh, there it goes. It's uninitialized. Ah, so it's warning me here, hey, you've got variables you didn't set values for. This is a helpful warning, right? A constructor's job is to give values to your attributes. You don't want strings to be null because you're going to get all sorts of weird issues here. So maybe we say name is nothing to start, right? Sure. And combat power is 0 to start. We can get some defaults. Or maybe we take them as optional arguments, right? Maybe we have a string for name equals a default here and a combat power int for combat power equals 0. You could do it that way. That's probably the cleanest way here, right? We'll say name, and then we have to add our this arrows, this pointers. Sure, that's nice. And now hopefully that, yep, now that goes away because we've initialized all of our attributes. Good job. We did the right thing with the constructor. Right. Trainer then, using namespace standard, include string here. So trainer had a bunch of other attributes, right? It had name, level, experience points, max number of fighting pets, and then a dynamic array of type fighting pet, right? A pointer of type fighting pet. We will initialize to be an array here. We'll have our destructor, copy, destructor, copy constructor, copy assignment operator, and then we need public methods for set and get for name, max number of fighting pets. That seems like a weird the attributes. I don't know what I did there. Probably just a bad copy paste. My apologies. And then get methods for level and experience points. We're not setting those things directly, right? A method for add experience points, and this one can change your level, right? This method, this public function here, can go and change our attributes, but we're going to control how that works here. Add fighting pet, and then add more fighting pet storage. All right, so name, level, experience points, dynamic array. Let's probably put that down here in our class trainer. Private and public. Here's our private section. Sure. So string for name, probably an int for level. That seems like a whole number thing here. An int for experience points, right? An int for max number of fighting pets, which is changeable, right? Just whatever our current max is. And then the dynamic array of type fighting pet. Okay, so this is a fighting pet pointer. Fighting pets or something? Sure. And it's like, oh, I don't know what this is. We got to add our include. Add the include. Look at that. It's going to type it for me. I love it. Sometimes the light bulbs are good. Sometimes they're garbage. That's okay. All right. So we've got that. Now we'll get to these in a little bit. Those are the hard ones. Get and set for name. You can change your name if you want. So sure. It's just 2. We can write these ourselves here. So void set name, given a string for name. This name is the name. And a string for get name just returns name. Okay, get and set for name. Good enough. Get and set for max number of fighting pets. Sure. Void set max number of fighting pets. Takes an int max number of fighting pets. This max number of fighting pets equals the max number of fighting pets. These are why they're boring to write here, but sure. And then an int get max number of fighting pets. Turns the max number of fighting pets. We should probably capitalize this one so it's pretty, right? Sure, gets and sets. And they're not the hardest thing in the world to write. They're just terribly dull, right? I like when the chatbot does work for me. Okay. Get methods for just level and experience points. Sure. Int get level. Returns level. Int get experience points. Returns experience points. Okay. Got those ones. Add experience points. Sure. So probably a void function. We didn't say it has to return anything here. So experience points. Yes, points. So what is this? If your experience points goes over your level times 1,000, increase your level, reset points to 0. Okay, sure. So take our experience points. Um, this experience points plus equals the experience points you just gave me. Why? Sure, we'll just copy paste. Okay, and then if my this experience points, right, make sure we're getting the current one here is greater than level times 1,000, level plus plus, and then experience points equals 0, right? You don't get to keep your remainder. Yeah.
How come you use then this in the if statement?
So because I still have this argument here, I want to make sure that I'm using my variable, my class level attribute here that I just added to. Yep. If you named something different, like XP, you don't have to worry about that. I'm fond of making these match. It's just my style, right? I think that makes it easier when you look at the IntelliSense when you're going to use the class. Oh, you want experience points, not XP. We probably know what XP means, but I'm inclined to make these things long and match. That's all. And if it doesn't, nothing else has to happen, right? That's it. We don't have to do anything. Easy enough. Um, right? I don't think we need any parentheses for order of operations because you don't have true times 1,000, right? We'll make sure this works okay here. I think that one works well for experience points. And then add fighting pet we have to take care of here. So if we need to know the next open slot, it means I have another piece of information I need to know. Right? It wasn't included in this list of attributes here, but if you need to know what the next open slot is, we need to know how many we currently have. So we probably want an attribute for current number of fighting pets, right? I didn't explicitly say it here, but that's the sort of thing, oh, I need to track that. Right? One of those aha moments, hopefully. So we can go add that, right? So we need an int for current number of fighting pets, right? And you probably even want to make that a get, right? And get current number of fighting pets. Fighting pets. I mean, sure. You don't have to. It's not necessary, but it makes sense, right? If you got an attribute, you might want to expose that here. So to add a fighting pet, right? So add fighting pet, given a fighting pet reference called the pet or fighting pet, sure. Now, we could either make copies or whatever, like the default copy here it should be fine because we're not doing anything with dynamic memory. The default copy will give me copies of these and life is good. Right? We're not super concerned. We don't have to do a lot of extra work for that. But passing the reference means they don't have to pass me a copy and I'm just going to make a copy of a copy. It'll be a little bit faster this way. I had one of my friends told me the way he likes to explain pointers and references is if you're going to your friend's house, you don't get a copy of their house, right? You go to where their house is. Right? That's your reference to their house, right? You're just passing them the address, not a copy of the house. I thought that was fun. Right, so to add fighting pets, we need to check, do we have room for it, right? If we don't have room, then we have to raise an exception. So if my current number of fighting pets is equal to my max number of fighting pets, then I'm going to throw, we have to include that stupid exception library, include standard exception. Okay, I should not know that, but that's okay. What, an invalid argument or something? Valid argument. Well, I don't know. Can't have more pets. I don't know. Something. It doesn't really matter what you give it here. So get some message is nice here. Or already at max, or I don't know. Go level up, go get good, whatever you want here. And if it throws, function stops. We don't need an else here. The else is redundant. So that's why usually we'll do our checks at the top in ifs, and then we just continue on with our code. Right? Save one level of indentation, makes it a little easier on your eyes here. So if we do have room, sorry, is that a question?
Yeah, so shouldn't it be more than max number of bytes?
So, so if I currently have 5 and my array is only size 5, there's not room to add a 6th.
Oh,
So I think checking to see if I'm at the max is the correct one here, right? Because if I have 4 and I have room for 5, when I put something at index 4, that's my 5th thing.
mm,
So it should work out pretty well, I think. So yeah, what we haven't done yet is the constructor. Right? We need a constructor, so we'll have our this is our trainer class here. Now, functions that don't have sets need a way to pass something in, right? But level maybe starts off at 1. I don't know, experience points at 0. Max number of fighting pets, we could default to something if we wanted. So maybe we don't even need anything here. You might not need any arguments here, right? We'll just say Name is nothing until you tell me otherwise. Level is 1. Experience points is 0. Experience points is 0. Max number of fighting pets. I don't know what we want to set it at. 5 to start or something. I don't know. And then current number of fighting pets is 0. And now we create the default array or the dynamic array. So we're going to initialize fighting pets be an array of fighting pets. So with the new syntax, new fighting pet array of size what? Well, size max number of fighting pets. Right? Start off at 5 because that's our max number here. No default constructor exists for class fighting pet. Oh, shoot. Yeah, we ran into that. So we have to go add a default constructor. I forgot. So how about we default number to 0? Now we get a default constructor. Oh, but we can't change number. All right. Well, we can go add a set number then, I guess. Void set number int number. This number equals the number. Not really a good way to get around that if we want to use our arrays here. Because without a default constructor, it's just going to be really upset. And we need a way to be able to change it here. So, okay, sure. No biggie. So I have a new array of fighting pets, size to max number of fighting pets. Now I have a place to put it here. So if I have room, then I'll take my fighting pet at index of current number of fighting pets, and I'll assign it a fighting pet that you pass me. You give me the reference, I'll stick it into my array. Doesn't match, built-in parameter. Oh, not fighting pet, fighting pets. There we go. With the S, right, to get my dynamic array. There we go. I use the singular match the argument here, right? So we'll assign it that value. Then I can take my current number of fighting pets and add 1 to it. Some people like to put it in here and think they're clever. I hate that because it's really easy to miss. That's all. You can put it in there because remember that post addition adds after you use the value. Just make sure you don't do the pre-addition, which somebody told me is faster, and I don't understand how, but okay, sure. So I always do it in the next line. I don't, if you like it in the same line, go for it. It doesn't really matter here. Okay, so if we have room, go and add it. That was it for add fighting pet. If we didn't have room, raise an exception. Okay. The slightly harder bit here was the add more fighting pet storage. Makes an array with a larger size, copies fighting pets to the new array, deletes the previous array. Right? We're dealing with allocating new memory, copying things over, and then releasing the old memory, saving the new one, right? The new array. So void add more fighting pet storage. If we wanted, we could take a number. If we just want to double, we can double. I don't, there's not a specific way we had to do it here. If you just want to add 1, you could go ahead and add 1, but that's going to be really slow. But we got lots of options here. So let's go make a new one. So we'll have a fighting pet array called new fighting pets equals a new array of type fighting pets here. And let's size this as max number of fighting pets times 2. We'll just double, right? We'll make our life easy. Okay. Then we'll take or maybe we even do it here. We do max number of fighting pets times 2, and then we can just use that value. How about that? So we'll double our max. We'll create a new array for the max, and then for index is 0, index is less than. Oh, we have to do this after. Shoot, because I don't want to copy a bunch of nulls. My bad. We'll go back and do the arithmetic here. So times 2, because we want to go off of the number of fighting pets we had here, index plus plus. Because that way we're only going to copy the previous ones, right, out of the old one here, make sure we're the right size. So we'll take my new fighting pets at the index and assign it the value of the fighting pets at the index, right? Take what was there, copy it to the new array. Take what was there, copy it to the new array. Yeah.
Wasn't there like the current number of like that's
Yeah, we could go off of current. I guess I'm assuming we wouldn't use this until we're maxed out, but maybe not. So maybe going off of current makes more sense. Yeah, we could go off of that. Right, so how many we do have copy off of. Okay, and then we can multiply first, right? There we go. I like that. That saves us 1 line of code. Or I guess some arithmetic, sure. Right, so go off the old one, copy to the new one. Go off the old one, copy to the new one. Then we can delete with the array notation, right? Because we're deleting a dynamic array of fighting pets. That essentially sets this to null pointer here. Then I can say, hey, that pointer now, you point to this new fighting pets pointer here, right? Point to this new location. So we've deallocated the memory we're not using, moved over, stored this as our current array we're working with for fighting pets. Here's we go, and we should be good to go. That should copy. Add more fighting pet storage. All right, I think we're pretty good. So now what we're missing is the destructor. How do we free up memory when we're done with trainer? Right, so that's the tilde character, which is really fun. Trainer. So to destruct this, we just need to delete fighting pets. Right, go and free that up. That was pretty quick. The copy constructor and copy assignment operator are the slightly harder ones. We're essentially going to copy, like we did here, but from the other one to this one. Right, slightly different as we go through it here, but similar idea. So we'll have a trainer that takes a constant reference to a trainer, I don't know, trainer, uh, constant reference or where do we put the constant here? Over here? Probably over here. And this is just telling us we're not going to change the thing you give me. We're telling you we're going to leave it as a constant value. So these other things we can copy pretty quickly here, right? So my name equals the trainer. Well, that's a reference trainer. I got get name. Can I have a get name in here? Do we not have a get name? I thought we had a get name. Trainer dot. No, we're just all right. Sure, we'll just get their attributes directly. That's fine too. Trainer dot level. Trainer dot experience points. Experience points. A trainer dot max number of fighting pets. And a trainer dot current number of fighting pets. Right. Then we need to make a new array for myself. So my fighting pets array equals a new fighting pet array of size current number of fighting pets. Right, I already copied that off of the other one here. So whatever they had, size it to that, or actually we should probably size it to max, right? Because then we have room to add more, right? So oversizing here, but whatever we currently have, we'll copy off that many. Oops, bad copy paste. Double. There we go. Oh my goodness, the double click usually works to highlight a whole word. Is this zoomed in too far? Is that a little better? No, I'm not. Still visible? Okay. So make the new array, and then we're going to copy. So for index 0, index is less than my current number of fighting pets, index plus plus, take my fighting pets array at the index and assign it whatever was in the trainer dot fighting pets at index. Right? Go to theirs, copy it to mine. 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 Okay? Now we've made a copy of this other trainer. We allocated new dynamic memory, and we've copied the values over. Right? So we're not going to have two pointers pointed at the same location in memory. We won't both have the same list of fighting pets, the same dynamic array of fighting pets. And then the last one, which is again almost the same here, is the copy assignment operator. And I have to go look at our GitHub here for that because I can never remember the syntax for that one. Here we go. So we had that one in exceptions and pointers. We did that in student, right? For copy assignment operator, yeah. Student reference operator equals given a constant one of those things. So it's going to return a reference, right? Which actually is going to return our this pointer because we're an existing object and we're assigning a copy of this other one to my existing object here, right? So, and then we do a little check to make sure we're not ourselves here as we go. Now this is trainer, give it a trainer, if we're not the trainer. And then eventually we'll return the dereference to this pointer because that is a reference here. The thing we're pointed at is the reference to the trainer, which is ourself. So as long as we're not trying to copy off of ourselves, it just saves us a hassle here. And copying off yourself and then deleting that dynamic array breaks things because you've deleted your own dynamic array when trying to free up space. So just make sure we don't delete ourselves, delete our list of pets here. Everyone would be sad. So essentially this is the same here, right? Actually, all of that I think is the same in here. Right? Copy their values from the trainer reference to ours, then allocate new memory. So but before we allocate new memory, because we're existing, the one extra step we have to do is delete that. So we say, hey, delete our fighting pets array, right? Free up whatever space we were using, get rid of it. Make a new one of whatever size it should be here, then go copy. When we're done, we can return on this reference here. Right, delete, copied over, new, copied over. Okay, I think that's all fine here. How's that look? Okay. Now we should try it, see if it actually works. right? Okay, so now we can go to a main file here. Again, there's no points for having your main file here, but if anything you've gotten, hopefully any code worth writing is worth testing. Make sure that your code does what it's supposed to do. Just because you wrote it doesn't mean it's going to work, right? It happens to me all the time. I mean, I do it on purpose so that you can see that all the code you write. No, it just happens, right? That's okay. That's why we test our code, right? So we're gonna go try a bunch of these things. We got to include trainer.h, and that should automatically include fighting pet because we're including that one, which includes that one. So I think we're okay here, but we'll try it and see. So let's make a trainer. We're gonna need the arguments here, and then trainer dot trainer dot train. Oh goodness, am I doing it wrong here? I don't need my arrow. Why is it so mad at me here? Trainer. It's just like IntelliSense is not working here. Trainer, lowercase t trainer. Do I not need the parentheses? Is that what I'm doing wrong? There we go. Okay. Because we didn't use the new notation. Okay, sure. So what do we want to do? Well, we want to set the name. Sure. Eric's the first trainer. We'll make another trainer. Trainer 2. Trainer 2 dot set name. We'll set it to Jeb. And we should add some fighting pets. Make a copy, see if it works. Right? So let's go make a fighting pet. Fighting pet. Because we're including trainer includes fighting pet. So you and this is one of the reasons putting everything in H files is kind of bad, because now there's a copy of that file inside of a copy of that file inside of a copy of this file. Everything we're doing is so small we could care less. In big projects, this is really bad practice. I'm just very lazy, and it makes testing easier. Is that right? We're acknowledging that fact, and I'm happy to admit it. It's okay. It just makes our life easier. It's not good, but we're fine, right? If someone else asks you to do it the right way, just smile and nod. You can take a couple extra steps. I don't want to bother. That's all. So fighting pet, right? And then, although this one we can pass some arguments if we wanted, right? We can give it a number 1, fire pet, because we can't use copyrighted names here, right? And then combat power of 10. Sure. So we got a pet, and then trainer dot add fighting pet here, given my pet. We'll add a pet, and let's add a different pet for Jeb. Make a fighting pet. Other pet. I don't know, other pet. And we'll call this one number 2. This is the water pet, and combat power 20 or something here, and trainer 2 dot set. No, add fighting pet, given the other pet. Okay, so now we each have a pet here. Now we can go and make some copies. See if we get some copies. We'll work with a third trainer. So trainer 3 is a copy of trainer, right? Now it should make a new instance here with new dynamic memory. So if I add a fighting pet to trainer 3, it shouldn't affect trainer, shouldn't affect me, right? Now we don't even have a good way to get all of these out yet, right? Probably want to add something like that to see if we can get these things out. Returning your pointer is a little bit risky because once you return that, then go modify it. If you want to, great, go for it. Maybe we have a get fighting pet and you give it an index, and we'll return a fighting pet at that index. That might be a little safer. We got options, right? We got lots of things we can go do with that, but let's see. So we made a copy, and then we'll make another fighting pet. More pet. I don't know. I'm running out of things here. This is the grass pet here, right? And then we'll take trainer 3. And we'll add the fighting pet of more pet. I guess we could have gone with the name here. That's okay. So let's go now and we'll fix that up. So in trainer, then maybe we have another function, right? We have oops, what is it? I don't like about this. Reading invalid data from fighting pets. Really? Trainer not fighting pets? Reading invalid data. I don't know what invalid data we're reading. That's interesting. And the current number of fighting pets. I don't know why it thinks that. Okay. Anyway, I got distracted. It's doing it here too. Interesting. Maybe I have a bug. We'll find out. All right, let's come down here. We'll have a fighting pet reference. I don't know, get pet, get fighting pet. Give it an index. And then we can check, right? Do a little sanity check here. So if my index is less than 0, or my index is greater than or equal to my current number of fighting pets, is an invalid index, or index out of bound. What is it? Index out. I don't know. Sure. Invalid argument. That's fine. Everything can be an invalid argument. Invalid index. Otherwise, we can return my fighting pets at the index. Right? Return that reference. Okay, now we should be able to get some fighting pets out. So Eric should have 1 fighting pet. Trainer 3, other Eric. I don't know. I guess we should change the name again here then, right? Trainer 3 dot set name for other Eric, or Eric copy. Here, Eric copy should have 2 fighting pets. Okay, and we can go and see if they work, right? So I don't know, for an index is 0, and this is kind of annoying here, right? I kind of want to write a function for it. Let's write a void function here. Void print pets given a trainer reference. Trainer. So if you give me the trainer, I can go print all their pets, right? So for an index is 0, index is less than trainer.get current number of fighting pets, because we added that function in here, right? Index plus plus, and then we'll see out the trainer.get fighting pet at the index dot get name. We'll just get the name of the fighting pet out here, right? So for every pet you have, go get the one at that index here. Hopefully should work for us here, and then we can print pets. Okay, so we'll do that for each of these. So we'll say print fighting pets. So just print pets. Print pets for trainer. Print pets for trainer 2, and print pets for trainer 3. Yes, maybe then we should just do this, I guess, at the start here before to see out printing pets for trainer.get name and an end line. We'll make this pretty, right? If I'm going to do it more than once, might as well turn it into a function, right? If you have the same code twice, you should feel bad about yourself. It's my good rule of thumb. I don't actually want you guys feeling bad about yourself, but just that's your motivation, right? Let's see if it works or if it crashes. We're trying the copy assignment operator, or the copy constructor here. So we get pets for Eric is the fire pet, pets for Jeb is the water pet, pets for Eric copy is fire pet and grass pet. I think that worked out, but now let's print trainer again, make sure that one didn't get changed here. Right, one last check to make sure that, okay, I changed the copy, did it change my original? And no, it didn't. You just have the fire pet. So I feel pretty good that our copy constructor is working, right? Now we can try the copy assignment operator. Okay, well, that's fine. Now, how about we change trainer 2 to equal trainer 3? See out assign trainer 3 to trainer 2 here. So trainer 2 equals trainer 3, right? This is assigning to this one. Okay, take this value, copy from this one, assign everything to here with an actual copy, and then we'll print out trainer 2 and trainer 3, and then we go modify them here. So then we'll take trainer 2, add a fighting pet. Let's go add, I guess we'll do that beforehand, right? See out, add electric pet to trainer 2. Trainer 2 dot, oh, we gotta make a fighting pet, goodness, electric pet, sure, electric pet. And then this is, I don't know, ID number 5, I forget where we left off here, that's like electric pet and combat power 50, I don't know, we're just making up numbers here, it doesn't really matter. And we'll add the electric pet, and then we'll go print out trainer 2 and trainer 3. So see if the copy assignment operator works for us here. So we added here, and we had the electric pet, so printing the Eric copy is fire pet, grass pet, electric pet. That's trainer 2, right? And then trainer 3, fire pet, grass pet. We never changed the name back, right? I guess we should have changed the name back. So that's the copy of a copy, right? So after we assign it here, maybe we can go change that. So then trainer 2 dot set name, Eric copy, right? Because 3 was a copy of 0, and now 2 is a copy of copy. I think that makes sense. Maybe it starts to get a little awkward here. So pets for Eric copy was 2, fire pet, grass pet, electric pet, Eric copy, fire and grass. Seems like it's working. Okay. Thoughts, questions, concerns? Just playing with dynamic memory. Dynamic memory is one of the reasons why our National Institute for Standards and Technology, or some whatever NIST stands for, is saying please don't use C++ anymore, or at least maybe think about not using it, because having to manage your own memory is error prone. Not that we're going to make mistakes, but it's easy to make a mistake. And if we make mistakes, that introduces possible vulnerabilities into our software, which gives malicious actors more opportunities to do bad things with the cool toys we build, right? We just want to build cool toys and make software that does cool stuff. Because it can do cool stuff, malicious actors can be like, oh, how can I abuse that cool thing? And this is why you can have a bad print driver that takes over Windows, or you used to, these sorts of things here. You get all sorts of weird issues. So, um, you know, there's ways to be better about it here. Um, and then there's this whole thing. We don't even get into it in iBooks, or I think it mentions it here. So it's a smart pointer. So smart pointers help manage dynamic memory and resource allocation, ensuring they're properly released when they're no longer needed. They're part of the standard template library in the memory header file. So you can use a unique pointer. This includes AI generated content. When you go Geeks for Geeks, they're probably AI generated this website too. I don't trust their content anymore. That's being nonsense, but let's see. What do we get here? Or you can use a shared pointer. Multiple pointers can share ownership of it. It deletes when the last shared pointer owning it's destroyed. So if you're using these pointers, they'll get cleared up eventually here. Right? So you can make these shared pointers of type rectangle. We didn't get to know what templates are, so it doesn't make a whole lot of sense yet. But you make a new rectangle using that new syntax, and then you can do things with it. And then when you're done with it, here it goes and cleans up here, right? We've assigned to it. It's going to clean up pointer one whenever we're done with it, which is cool. And then weak pointers doesn't even count it at all. Sure, it's whatever. But these make it a little bit better. So they're adding new features to C++ to help us avoid these sorts of issues. But we still need to know how the old stuff works before we just use the new magic stuff. So we typically don't even get into these till later classes, but they're super cool and help us avoid some of those issues. Crucial part of modern C++ programming, providing a robust and efficient way to manage dynamic memory and resources and make sure we don't forget, right? Which is cool. All right. Let's see. Look into the rubric. Right? We have private attributes and get methods. We got a constructor, copy assignment operator, a destructor, add experience points, add fighting pet, add more fighting pet storage, and private attributes public get and set for fighting pet class. Cool. I think we hit everything on the rubric. Awesome. All right, should we move on to new stuff? Yay, new stuff. Okay, so let's talk about inheritance. Now, ideally, you talked about this a little bit last semester, right? A little bit? Okay, good. A little bit, none. Okay. Boggles my mind how that happens, but okay, sure. Let me start up a new project. Oops. And why we need to do pointers first is we get some cool magic that happens when we use pointers here that we don't get when we're not using pointers. So you'll see some of this cool stuff. So this is week 5 inheritance. All right. Using namespace standard because we're lazy. Okay, so we can go add a header file. It's called, no, I didn't want to call it header. Let's call this one rectangle. So we'll have a class for rectangle. Class rectangle. That's a private section and a public section here. Now rectangles are pretty easy. They have a height and a width, right? Height and a width. Width. I need more coffee or possibly less coffee at this point. This is cup 7. The answer is always more, right? So to make a rectangle, you probably know what the height and width are, or maybe you want to set it. Right? Totally up to us. Either way we want to go about it, here's fine. I like having a constructor because I think that makes life easy for us here. So we'll have an int for height and an int for width. And we'll say my this height, that arrow, equals my height, and a this width. Look at that, suggesting width equals the width. Okay, so we can make a rectangle, and then we'll have an int for get height, returns height, and an int for get width, returns the width. Okay, super boring. Other things rectangles can do, right? We can have an int for get perimeter, or parameter, right? We're going to return what height plus width times 2, right? Or 2 times that plus 2 times that, however you want to do it here, right? Whatever arithmetic you want here is fine. And then for get area that returns height times width, right? That all seems reasonable. Now, maybe people can change the size of the rectangle. Sure, that's fine. If we want to allow them to, we can do that. So we can have a void for set height here, takes a height, and we'll take an int here for height. This height sets it to the height, actually this line here, right? We'll go do this one. Now, if we want to get fancy here, we can check and make sure this will obey the laws of physics. Is it physics? It says rectangles have to have a positive number here. I guess 0 is technically, you can have a one-dimensional shape. I don't know how that works in real life, but we can pretend here. So we'll say, hey, if my height is less than 0, we'll throw, let me go include our standard exceptions here, an invalid argument, invalid, really? Invalid argument can't be negative. Didn't I include that? What's it? Using namespace standard. Yes, the standard namespace. Okay. Now that one's happier. Okay. So if we've got this here, we probably want to use our set height, right? Set height function, because we don't have to have the same sanity checking code twice. And we'll do the same for width here, right? Just rename it width everywhere. Set width. Just that word here, and that word, and that word, and that word, and that word, the capital W. And we got all the widths here, right? Can't be negative. Right, so you can set the height, you can set the width, probably use set width again here. Right, we do our sanity checking in the constructor. Great, set some values here, we're good. We've got a basic class here, not super interesting, but we got some features here, so we can set them. The next thing we can do is we can make a class that inherits from rectangle. It can do all the things rectangle does, but be special. Right? Inheritance creates an is a relationship. It is a rectangle, but it's a special kind of rectangle. And you can change the behavior, what makes you special. You can add new functionality, you can change the behavior of your parent class or super class or base class. I don't really have 3 different terms for it, but you've got parent class and child class, you've got base class and derived class, or you've got super class and subclass. Sure, whatever people want to call it here. We love our names for things here. So let's go add another header here. We'll call this one square. Squares are rectangles, right? So we're going to include rectangle dot h here. I'll have a class for square. No parentheses there. Private section, public section. Now, square doesn't need any extra attributes, right? Because we already have width, we already have height. Nothing new square is going to add here for us. But what's going to change is our constructor. We don't need a width and a height, right? We just need our width, right? Or length and width, for whatever we call them here. So we just have a width, right? You give me the width of your rectangle. Now, what we're not doing yet is we haven't pulled the, oh, I'm sorry, we have to inherit here. So in the parentheses here, now we say we're a rectangle. Or no, colon, rectangle. There we go. Never remember the syntax. There we go. So we use this colon to say, hey, I'm going to inherit from this class. I am one of these, right? A square is a rectangle here. And now it's warning us there's no default constructor for rectangle. We can't create a rectangle without giving it some arguments here. So we have to say colon and we say base, width and width. I think the base, is it rectangle, square, rectangle, width and width. Okay. Syntax is always weird. So say, hey, my constructor takes this one here. When my constructor gets called, call my parent classes, my base classes, my super classes constructor, and for its length and width, give it my width. Here. We want to do this thing with this value instead. Right? So you can create a square with a single value for width, and we just pass width for both of those. Okay. The next thing we need to do is we have to change some behavior. We need to do something special here. Because my rectangle class has a set width and set height, if you are able to set the width of a square and not set the height of a square, you're no longer a square. We've done a bad thing. One of those ideas with object-oriented programming is we've encapsulated all of our details together and we can protect the integrity of our class. We don't let people do bad things to our class. Right? If a square says you can't have a different width than height, don't let them make them to be different. So to do that, we just override the behavior. We're going to add another function here for set width here that matches our parent class here. It takes an int for width, and we'll have a void for set height here, an int for height. So by having our own functions, when this one gets called, it'll use our version here. Well, what do we want to do? I want to call my parent class's version here. So we'll call, is it rectangle? Oh, super. Oh man. Okay, I have to go. I guess we can open up the Zybooks, right? Is that okay? Because I don't remember off the top of my head. Go to inheritance and look at that. Yes. So we need to override it. So we're going to override its behavior here by adding in this functionality here. Okay, so yeah, superclass : so you get that scope here. So it'd be rectangle : set height given the width, and rectangle : set width given the width. So if you set one, I'll set both, right? Using my parent class feature, right? And if you want to set the other one, I'll just repeat it again here, but now for height, sure. So we still have the functions, but we've changed the behavior to make sure that we stay a square. If you want to change one, I'm going to change both. Go to my parent class, do this thing. Go to my parent class, do this thing. Okay, so we've marked this as doing, hey, we're going to make sure we take care of that. Now that's good. I think that takes care of it here for that one. Okay, so now we can be a square here. So let's go make some squares here. So let's go include square, square.h. Okay. And we can even ask the user if we so cared to. I don't particularly care to, so, but we could if we wanted square, small square, and then we'll say, hey, this one is, I don't know, 5, and then a rectangle, large rectangle, I don't know, is 10 by 20 or something here, right? And it'd be nice if I could go and get these values out, right? And get the area of these things out with another function, right? If I could have, here's a void, I don't know, print rectangle details or something here that takes a rectangle reference, that one here, rectangle, right? And we'll just say cout area and rectangle dot get area, and then line and the cout perimeter, rectangle dot get perimeter, and then line. So we can go print our rectangle details for the large rectangle. But if we want to print our rectangle details for the small square, it doesn't work. And now we're sad, right? Because small square is not a rectangle. It doesn't work for us. But it is a rectangle, right? Squares are rectangles. This should work for us. So now we get to do some fun things here. So instead of taking a rectangle reference, let me go make sure I'm doing this right here. We do our polymorphism. There we go. So you get compile time polymorphism or runtime polymorphism. This is the really fun one here. So at runtime, we're going to figure out which is the right version to use, not when we get compiled, which is really neat. So when we override things, we can do fun behavior here. So we say if we use pointers here, we can go and say, I'm going to give you a pointer to this particular thing. Where is it? Our pointer. So you take a business pointer, and it can take a business or a restaurant. Restaurants are businesses. Here's just a special type. That was the section we skipped up above. So if I take a pointer to a rectangle here, and then this is what? Arrow get area now, and arrow get perimeter now. Now again, these aren't pointers right now, so I need to say, hey, small square, square pointer, small square equal to new small square, new square given that, and then rectangle pointer, large rectangle equal to new rectangle, right? So we're using that new syntax here. Now I can pass small square and large rectangle as pointers. No, still not. giving me the pointer here. Do I have to dereference? No, I should take a pointer. Did I do it wrong? Business pointer. Pointer get description. Do that, right? Why is it being cranky here? Small square. I shouldn't be. Conversion inaccessible. No. This one should work. Conversion not allowed. Syntax error. That's a weird error. But inaccessible. Conversion from square to rectangle exists, but it's inaccessible. Conversion to inaccessible base class rectangles not allowed. What did we do wrong here? I have to go look at their example again. Business. Oh, public. We missed the public keyword here. So in rectangle, you have to say public rectangle. Is that it? No. What did we miss? Class restaurant, public rectangle? What business? Oh, no, not here. That's why. This one up here. Now, is that happier? Yay, okay, now it's happier. So we missed the piece saying, hey, we're the public everything of rectangle rather than just the rectangle. I don't know why that's so important, but sure. Now this works when we run. Oh, really? Expected a semicolon. Where am I missing a semicolon? At the end of our class? Really? Oh, I did have one here. Wow, friends, I don't remember anything anymore. Definitely need more coffee. But now we get our rectangle. Yay! So we get squares. Area is 25, right? 5 squared. Perimeter is 20. 5 times 4. Rectangle. Area 200. Perimeter looks good. So if we use pointers, this works. This is polymorphism. It's treating something as another type, right? Where you say you can treat a subclass as its parent class type because it has all these same functions. It has a get area, it has a get perimeter, it has those functions here. Now, what we need to do is add in a keyword. So we're missing a little piece here. This is that's the base class. Where is it? That was in the next section. That's right. So we have to add in the keyword with this virtual keyword here. So when we create our class here, we're going to say, hey, this is a virtual function, which means I'm planning to override it. I want it to be able to be overridden here. So when we do one of these things here and we go, let's go, just for fun, we'd say rectangle dot set width or height, I don't know, to 1. Just to screw with these shapes here. If we set it to 1 here, I get 42 and 12. Well, 42 makes sense, right? Because we were a 10 by 20 and now we're a 1 by 20. So that one makes sense, right? Where did my output go? There's the output window, right? But area is 5, but I set it to 1. It should have set both, but it didn't. So we're getting polymorphic behavior except for those functions, right? When I called set width now, it didn't do what it expected it to do because it ran the rectangle version here. So I'm going to put a breakpoint in. And if we run it in debug mode, we're going to see it uses the rectangle version. So if I step into, we get, this is the set height for rectangle, right? Even though this here, oh, I'm sorry, this one is the rectangle, so that's good. So we're setting it for rectangle. And then let's print the details, go to the next one. Right now for the square, let's step into. When I step into rectangle set height, I still get the rectangle version, right? Get that in a second. Okay, now I see I'm 5 by 5, but I'm about to change just one of them here, the height. Well, now I'm no longer a square. Bad things happen because we use the rectangle version. We said, hey, this is a rectangle, so we got the rectangle version. If we add that keyword here, we add the virtual keyword here, we'll say, hey, I'm planning to override this at some point. I want this class to be able to be inherited from, and I want these things to change, right? So we have to add a keyword here. Then in the square version here, we have to add the override keyword. And say, hey, do we not add override? Shoot, void? I thought we did. Oh, goodness. Do we not? We added at the end. I already had one at the start and one at the end here. Sure, override. Well, at the end of the function, because reasons. So now we're going to say, okay, I want to override my parent class's virtual function here. And if we don't have that, it should yell at us, right? If I remember right. So if we don't have that one here, now it's going to yell at us and say, hey, you said this is override, but it's not overriding something. Something didn't match here. Right? You have to have it be declared virtual so that you can override it. So these go in pairs here. So we'll put virtual back. Now override works. Now what happens is we get polymorphic magic. So not only can we treat this class as a rectangle here, but at runtime, so let's go over the rectangle one. Let's go back to this one here. So at runtime, while the program's running, I've said, hey, this is a rectangle pointer, call set height. But when I step in now, I get square set height because we marked that as a virtual function that's being overridden. While it's running, C++ says, oh, go do the thing that you actually are, because it knows it's a square pointer, but it happens to fit in a rectangle pointer shape because it is a rectangle. But now we're going to get the correct behavior, and we'll keep ourselves square shaped here. Now my height and width are both 1 because we changed one of them, right? And now my area and perimeter should all be pretty happy here. Right? Area is 1 and perimeter is 4. Pretty cool magic. So that's polymorphism. Feels like a lot of magic, but it only works with pointers. We don't get this behavior if we're just using references. So this is one of the reasons why we use pointers, because we want this cool polymorphic behavior where I'm going to define it once. And if you want to go change it, go for it. Make it special, and then I'll do the special thing at runtime. Right? I can treat them all as rectangles, call the functions that exist in rectangle, but while it's running, it'll go do your special thing. Right? Without that, life gets a lot harder. And then we'll see this worked really well when we get into the next advanced topics. We start talking about containers and our ADTs and all sorts of fun things here. So this is a core functionality here where we get the correct version that we're looking for because we're using pointers. Right? All thanks to that magic, which is pretty cool. All right, I think that's probably pretty good for now. Let's see, how far else do we get here with these? Yeah, so we didn't get to abstract. We'll talk about abstract on Thursday. One thing I want to caution you on is once we've done inheritance, for some reason, y'all like to think inheritance is the only tool you have and that everything should be inheritance. And that's definitely not the case, right? Okay. When we do like an example with a grade book is not a grade, and a grade is not a grade book, but a grade book has a lot of grades, right? So there's an is a if it actually is one of those things. Otherwise, it's just a has a. My grade book will have a lot of grades. There's no inheritance. You don't need inheritance there, right? Because they're different concepts, right? But if you think of like hierarchies, like the kingdom, phylum, class, order, family, genus, species in biology, which is still in my head 20 years later because I don't know why, but sure, right? All mammals, right? That's the a high level, right? That's our order, kingdom. I forget whatever it is. Kingdom Mammalia. That sounds right. Right? We all share common traits, but then what makes us special, right? Cats are not humans. We're both mammals, right? So that could be an is a relationship. Whatever is shared is the is a, and then you make those special subclasses what makes us different here. So there's lots of things you can use inheritance for, but it's not the only tool you have. Okay. We'll talk more about that. And then we'll look at UML is a great way to draw pictures of these things here. Right? Having a picture really is worth 1,000 words when you're collaborating, when you're just getting your ideas down. We can draw a nice little picture of something. We can tackle that on Thursday. Does that sound good? Right. The next, yeah.
I have one question. So, in the main file, I seen you, include the square header
Mhm.
file.
Yep. So the same idea, because square imports rectangle or includes rectangle, it's doing that for me already. Yep. So essentially when you include an H, it copy pastes it. So it's saying what is in that H file, put right here. And one of the things that has is an include for the rectangle. So it says, oh, now copy paste rectangle.
Oh.
So you get this. It's messy, but it works well for us. Yeah. All right. Then we're gonna talk about the last project here, or I'm sorry, the next project here. So we'll go project one, uh, one inheritance and polymorphism. Look at that. It even knows. How cool is that? So 2 weeks from today, 3:30 p.m. Goodness, why can you not figure out what I mean? People say like computers are going to take over the world, and I can't get a date time picker to understand what 3:30 p.m. is. I just don't buy it yet. That's okay. So we'll call this one probably 15 points. We've got more things we're going to do here with this one.
Can we put it 4 p.m. too?
What?
Can we put it like 4 p.m. please?
Well, I'm going to start going over it at 3:30,
Okay.
right? First thing in class.
Okay.
Um, it'd probably take me more than half an hour to solve this one. Probably like 45 minutes for this one. It's a little bit bigger, but like once I start going over the solution, I can't take it. Um, okay, so please submit the URL of your project folder in your repository. Okay. And we're going to go, let me go shamelessly copy paste here real quick. And go back to Canvas, other classes. No, what am I doing here? This one. Here we go. Yeah. Okay. So we're just pretending here we're going to build some classes for our game. So, and also add your self-assessment, right? Use the rubric, score yourself. So we're going to write our classes, and then we're going to also test this one as we go. I didn't show you tests yet. Shoot, I got to show you that on Thursday. Remind me to show you the testing on Thursday. Some classes, and I can't. Where'd my cursor go? That's really weird. I lost the cursor in the box. Canvas is weird. Here. Okay.
It's on the board.
Is it? I don't see it on my laptop. That's crazy. Wow, I've never seen that before. All right, we were doing this in Python, so our version is a little different here, or just our terms for this. This is gonna be annoying. That's okay. It's range, position. Okay, so we're building out the classes for a game here, but we're not actually writing the game itself, right? When we're working on large software projects, you break things up into pieces. So all of that you're tasked with for this exercise is writing the classes here. Move, tech, power. So we're going to write a couple classes for our game here. We're going to use inheritance for these. Power, points. There we go. Let me just fix some of these up here. Sorry. We use snake casing instead of camel casing. Okay. All right. So 4 classes for our pretend game. The first class here is unit. So everything will be a unit. We're going to inherit from unit. That's our base class. Everything is a unit here. So units have attack power as an integer. They have hit points. Oh my goodness, I can't spell points here. Hit points. No, print. Hit points as an integer. When this changes, we want to make sure it stays between 0 and max. So you can't go less than 0 for your hit points. You can't go above the max with your hit points. So this is probably not something we're setting directly. It's probably there's going to be another function that changes it, and that one keeps it within bounds here. We'll have a range. We're going to default our range to square root of 2. So that's actually probably a double here then, right? If we've got the square root of 2, probably not an integer, my mistake here. And then we're imagining that we're playing this game on some sort of 2-dimensional grid. So you've got an X position, you have a Y position. If it was actually in space, you'd have a Z, but that's just a lot of work here. And I don't understand how to do distances in 3D. It's okay. We could look it up, but we don't need to here. And then we're going to have a team. So you're going to be on a given team here. So that's just a string value here. And then we'll have an is alive. This is an attribute. It could even be a function if you're alive or not. I don't know if you need to keep it as an attribute. That's just a Boolean value of yes, you have hit points. So if you have 0 hit points, you're not alive. If you have hit points, you are alive here. And then we're going to have some functions. So you can attack target here. Now, this needs to be a pointer, right? A unit pointer target. This way, if it's a pointer, polymorphism will work for us, right, if we're using pointers. So magic will happen here if we're using pointers. So we can attack a given target. So you have to find out if that unit is within range. I said triangle theory. I guess this is the distance between 2 points, right? Distance between 2 points, right? Your x difference squared plus the y difference squared is the total distance squared, right? Just to make a triangle out of them. Okay. And then see if your team is someone that should attack that target. So the us team fights the them team and the chaotic team, right? So we've got 3 different teams, either us, them, or chaotic. Team them fights us and chaotic. And then Team Chaotic just fights everybody. They're nobody's friend here because they're just sad and lonely. Okay. So if they're within range and they're not your team, and also can't, however you wanted to figure that out here, right? Couple things we're checking here. We'll go attack them. When you attack, you reduce their hit points by your attack power. Right? I guess that should be. Let me go grab that here. So that's what attack does. Right? When unit fights, attacks, units attack. Reduce the target's hit points by the attacker's attack power. Okay. Then we also have a move function. So move will move along our x, y coordinates here, right? And you might need some arguments here. You might not need some arguments here. We've got lots of ways we can go about it here. Um, so attack should definitely be a virtual function here. Virtual function here. Move will be better if you make, yeah, it should be virtual. Again, there's some ways to go about it here, but whichever option you want to go with is fine. Right? And we have infantry, right? So infantry is a unit, right? Inherits from extends unit. It has an attack power of 5. So all infantry have a set attack power. They all have a set hit points here. When infantry move, they can move either X or Y, 5 units or less. So positive X, negative X, positive Y, negative Y. As long as it's 5 or less, you can move that far. Right? They move along our two-dimensional space, but only X's and only Y's. So they're kind of like rooks, right? They can't go on diagonals here. Okay. And then we have an artillery class, extends unit. Here they have a bigger range. It ranges 10, attack power is 10, but they only have 1 hit point and they only move 1 X or Y at a time. Right? They move slow, but they have a longer range and they can attack. And then we'll have cavalry, which extend unit. Here, range is 5, attack power is 5, hit points is 10, and they move 10 at a time here. Okay. Then the last one here is captain. Captain extends the infantry. So captain is an infantry. Infantry is a unit. Right? So you can have this multiple levels of inheritance as we go. So they have an attack power, they have hit points, but what's different about them is their attack function rallies a friendly unit, which restores all their hit points. So if it's a friendly unit, so us will rally us, them will rally them, there just won't be any chaotics because they hate everybody. So just don't worry about if they're chaotic here. You just restore all their hit points. Like, hey, I'm here to help. I'm the captain, and everyone's like, yay, I feel better now. I can keep fighting. Okay, so we're just writing the classes and the unit tests. So I'll show you unit tests on Thursday. So unit testing is a better way of not having to write a main function and look at our output. So we'll spend some time doing that on Thursday as well. Okay. All right. Awesome. Oh, sorry to run over a little bit here. So we got lab tonight. We'll practice lab on inheritance and also finish up last week's lab if you haven't finished that yet. We can go from there. Okay.
Okay.
All right, thanks, folks. I'll see you in a little while.